So we'll now revisit the idea about short circuit evaluation. Remember the context of speaking about this topic previously. So we try to use the short circuit evaluation to guard integer division, so to prevent any division by zero from happening. And now we're going to use the same logic over here, and then we want to guard array indexing. Basically, every time you try indexing into an array, you want to make sure the index I or any integer expression must be a valid index, meaning that it should be between 0 and also array.length minus 1, right? That's kind of the principal idea. But let's see one example to show to you exactly how you can use it. Let's consider this problem over here. Let's read it together. We want to ask the user about how many integers they would like to input. And then, for example, if they want to enter 3 integers, then we'll prompt them for 3 times. And then eventually, we will ask them, after they have entered all the numbers, we want to ask them for an integer index. So that should be, presumably that should be valid, right, from the user. If they're well behaved, it should be valid. And then we want to check to see whether the index into the array should really store an even number. Okay, you can see over here, should be even number. And let's say we'll consider that as an error if the number store at a particular specified index is odd number. So that's the problem we are trying to solve. So here is one example run from the console. Let's say the users say they want to enter 2 numbers, let's say 23 and 24. And now they say want to enter index 1. You can think about index 0, index 1, right? So index 1 is actually even number. So you would say it's an even number. If you say index 0, in that case, it will be an odd number. Okay, it's a very easy program. How would you program this? I would suggest before you actually look at a solution, maybe try to program this quickly by developing some console application before you move on. That would be some very nice exercise for you to practice, for example, the while loop. All right, assuming that you have thought about it, let's now take a look at the solution quickly. Okay, and I will go to iPad in just a moment, but let's see what how the program should look like. One example solution. Let's say we declare a scanner and then prompt the user for how many integers do you want to enter, and then let's say the user might say how many over here, right? So let's assume that how many would be simply either 0 or 1 or 2, non-negative, right? Let's assume that. And then we simply create the array accordingly. You can see how many over here depends on what the user really entered from the console, from the keyboard. Okay, that one's easy. By the way, this is something that you actually already saw from your lab exercise, the console application we gave to you. But now we just want to explain that just in case you get lost when you saw the program before. And then we'll simply just say, since the user wants to enter this many numbers, so we'll simply prompt the users for this many times. So for every iteration, ask them to enter an integer, and then we'll simply store. You can see the I here, the loop counter can be very conveniently used as an array index. So you can say ns at position I, index I should be equal to whatever the user entered, right? That's something you should know already. All right, and then we say tell the user, so now that you have already entered an array of integers, tell us what index you want to check into. And the user is going to give you some, the user is going to type on the keyboard, give you some integer I. All right, and the I will be very critical, that's why I highlighted in yellow. And then we'll try to see if the ns, remember ns is the array that we created, and it has stored this many numbers. If ns at position I or index I modulo 2 equals 0, meaning that it's actually even number. In that case, we'll say it's even. Otherwise, you can imagine we may have some error message over here to say it's actually odd, right? So that's a solution. Hopefully that makes sense to you. All right, so now here is my question for you. Does this program here always work? It compiles, so compilation is not an issue. So the issue is really about logical. Will this program here always work without crashing at the runtime? So that's my question to you. All right, pause the video, think about it. Assuming that you have thought about it, I hope. So now let's see. The answer is not always, meaning that depending on what a user enter over here, it may work, it may not work. When it doesn't work, it might just crash. Specifically, you can see you're using I directly from the user as the index into the array. What if the user is not well behaved? Maybe they enter an index that's way too small, for example, -1. Or they simply enter some integer value that's way too large. For example, ns.length or ns.length plus 1, plus 2, and etc., right? All right, let's see here. So it will work if I is actually in the correct range, right? That's a correct range, valid range for the array indices. It wouldn't work if, remember De Morgan, right? You can think about if this range constraint is actually false. So that means either this is false, in that case I will be strictly less than 0, or De Morgan, this is not the case, which means I will be larger than or equal to the length, right? So if it's either too small or it's too large, we're going to crash. Okay, so this will be so-called array index out of bound exception, right? That's also something we talked about previously. Let me illustrate to you very quickly. Okay, so you can think about everything we have talked about up to here, right? So everything up to here is actually pretty straightforward, and then we're simply reading the input integer from the user, and then you're going to store that into I. Okay, let's now talk about two cases. What if I is actually -1? In that case, I will be -1, and you're using that directly. So now -1 is definitely an invalid index for NS. Let's say we try to store 3 numbers into the array. So that's going to crash. So it's going to be array index out of bound exception for sure. Similarly, if you also enter 3 over here from the user, right? So let's say user enter 3. That's something too big. And then you're using NS3 directly. And 3 is also an invalid index. It's way too large. So that will also crash. You also get array index out of bound exception, right? It's a very simple illustration. Just want to show you quickly. And then for the rest of the example, let me, before I go back, let me just talk about how you can fix it. The answer is the fix will be you want to guard. Okay, so what's the resolution to this issue here? So the resolution to array index out of bound exception. So the resolution really is to use the short circuit evaluation. And when we talk about short circuit evaluation, you can either use conjunction or you can use disjunction. You can use either way. Okay, you're going to use either of these to guard array indexing. And specifically to this example here, the array index that we are concerned about is I over here. So it's really about NSI, that this is the expression that we want to guard. But how exactly do we guard it using either conjunction or disjunction? Let me show you right away. Okay, let's talk about conjunction first. Okay, so the only thing I changed to the solution was this expression over here. You can see here. You can see this is the part I added, and this part is just the same as before. So this is the array indexing to guard. Okay, specifically, of course, this I over here. We would like to guard this particular indexing. So how do we guard it? We want to make sure before you can evaluate this expression here, you must make sure this is true and also this is also true. If any one of them is actually false, you're going to just conclude the conjunction is simply false. So that's the very definition for short circuit evaluation. So for the basic discussion about short circuit evaluation, you can refer to our previous lecture about when we talk about if conditionals, right? You can also use the array indexing for guarding division. You can look at that, right? I'm not going to repeat over here. All right, so let's just try very quickly about input over here. Let's say we try -1, which caused some crash previously, right? If the array indexing is unguarded. Let's say -1. So let's say I here, if simply just -1. So you will get -1, let's just, basically I'm going to copy this. 0 less than or equal to -1, and also this one here, -1 strictly less than ns.length. Let's say ns is over here. That length will be simply 3. And also ns, in this case, I will be -1. Modulo 2 equals 0. So now are we going to result in a crash? Let's see. According to the short circuit evaluation, you can see this part here, 0 less than or equal to -1 is already false, which means the rest, according to short circuit evaluation, the rest of the expression is simply bypassed. We simply just don't need it. All right? Hopefully you can see that, right? So that means this part over here will not be evaluated. because this part here is already false. All right. Let's see the second input over here. Let's see when I is equal to 3. It's going to be very similar, but let's just still do it. So now when I is equal to 3, okay? So now, first of all, we're going to evaluate this. So 0, let me just move this to maybe here. Okay, just give myself a little bit more space. Okay, so here, 0 less than or equal to 3. And also this one here, 3 less than ns.length will be simply 3, right? This array that we're talking about here. And then, and ns at position 3. Apparently, this indexing should be itself in isolation should be invalid. But are we going to result in a crash? The answer should be no for a very similar reason, but let's see why. You can see this part over here, 0 less than or equal to 3 is actually true. According to short circuit evaluation, should we continue? The answer is yes, we should continue, right? So this means, well, we're going to continue, and then 3 less than 3 is false. So that means we're going to bypass this part over here. So this part here will be bypassed. And this particular expression here that might result in a crash will not be evaluated. All right, let me summarize very quickly. So in the case of conjunction short circuit evaluation, you're going to put before the expression that you want to guard, you want to put all the valid constraints about the index. You want to make sure it is actually not too small. It should be larger than or equal to 0, and also it should be not too big. So that should be strictly less than the length of the array. Only when these two are true are you then going to evaluate this. If any one of them, for example, if this one is actually false, or this one here is false, according to short circuit evaluation, you will simply bypass the evaluation for this array indexing. So if you try this in Eclipse, if you simply try -1 and also 3, you will not see any crash. You'll simply just go to the else part. And for the else part, you can make it maybe fine-tune it, and then try to make it maybe more informative to say, in this case, the index is simply invalid, right? I'll leave that as an exercise for you. Okay, you can see that's some hints for some exercise for you. Okay, I'll put it here. So the error would be something you can do as an exercise. That's something you can fine-tune yourself. All right, so that's about using conjunction. Let's see the use of disjunction very quickly. Okay, so now for disjunction, what we will do is we're going to basically say this is the condition that we want to guard, right? NSI. So this is something to guard. And then before that, we want to say either when I is strictly less than 0, or when I is larger than or equal to length. You can think about in the case of disjunction, we're trying to specify the invalid condition instead, right? You can think about here, this and this. Let me just try to make it more obvious to you. You can think about here, this condition here and this condition here. So these are the valid constraints in the case of conjunction. On the other hand, so that means you will only make sure both are valid before you can actually evaluate this. That's it for the conjunction. On the other hand, you can see this one and this one here. So these are the invalid constraints. I less than 0 and I larger than or equal to ns.length. These are the invalid constraints. How do you interpret that intuitively? You're basically saying either it is invalid here or this is invalid here. If either of the invalid constraint is actually true, in that case, you're going to bypass the rest over here. You just simply don't evaluate that. So that's the intuition. Let's try to see this, okay, quickly. Now, what if we got -1 over here? Okay, if you got -1, so we have -1 less than 0, or this one here, -1 larger than or equal to ns.length, which will be 3, right? We're still talking about this array over here. Okay, and then or ns at position -1 modulo 2 equals 1, for example, right? And let's see what's going to happen. you can see this part over here, -1 less than 0 is actually true. Agree? And then -1 larger than or equal to 3. Do we need to evaluate it though? The answer is no, because remember for disjunction short circuit evaluation, as soon as the operand you're encountering is already true, so that means this part over here will just be bypassed entirely. Okay, so this will be bypassed. That means this part over here, even though in isolation it will cause a crash, but in this case, since this part is already true, so that means this we already know it is already invalid for one reason, because it's strictly less than 0. So that means this will not be evaluated. So hopefully you can now really appreciate the beauty about using the short circuit evaluation to guard some expression, in this case array indexing. Let's now do, for completeness, also when I is equal to 3. Okay, so when I is equal to 3, let me also move this away over here at the top over here. Okay, let's say if we are reading 3 over here, let's say here 3 less than 0 or 3 larger than or equal to ns the length will be 3, right? Or ns at position 3 modulo 2 equals 1. This expression in isolation should really cause a crash, but since it's put in the context of short circuit evaluation, it may not be evaluated. Let's see. So here, let me use green over here. You can see 3 less than 0 is actually false. And for disjunction, if it is false, we still have to evaluate further to decide the overall result, right? That's something you can review from the previous lecture. And then 3 larger than or equal to 3 is actually true. So that means we can bypass the rest according to the short circuit evaluation for disjunction. So this part here is simply going to be bypassed. Specifically, this part here is not evaluated. Alright, so hopefully it makes sense so far. So that's about how you can use the short circuit evaluation for either conjunction or disjunction to really protect the array indexing. Just one more recap sentence to say. In the case of conjunction, you will specify the valid constraints for the conjunction. And then for the disjunction here, since you want the invalid constraint to make it true, so that you will stop evaluating further. So that's why these two constraints will simply just be the invalid ones for the array indices. All right, and then I'm just going to give you some exercise to think about. Right, I'll leave the pages clean to you, but let me just talk about the two exercises for you. Okay, and then when we go over the slide, you might just find some similar solution anyway, but as many exercises for you as possible. Let's say this. Let's say we got this particular combination over here. You can see this is what we got. Oh, sorry. Let me say that again. So this is the conjunction solution that we got, right? So now I'm saying that, can you simply imagine to change line number 10 into this particular line over here? So specifically, you can see this is the constraint that we would like to guard. However, it's not put in the middle rather than the rightmost expression. So now, is this going to work? Is it going to work? Number one, or is it going to crash? So that's something for you to think about, right? That's exercise number 1. Exercise number 2. This is the solution that we got for using short circuit evaluation of disjunction. And then let's say we want to change that to the following line over here. So we still have I less than 0, we still have it, but now we kind of swap the order, put this into the middle, and put this as the last. That's basically what we did. And then, so here, this is the expression we would like to guard. So now, you want to justify whether it's going to be a crash or is it going to be working. Okay, either way. Okay, so if you choose either 1 or 2, you want to justify. And maybe by using some example input, you can think about the test input I already gave to you over here, right? So these are the 2 exercises for you to think about. So the critical point for solving this is by considering the order of evaluation. Always go from left to right. And then consider whether you're talking about conjunction or you're talking about disjunction. Apparently, there's a typo over here. Let me fix that right away. Okay, I really meant to put over here disjunction. Sorry about that. Okay, there we go. Okay, so think about these two, and then let me go back to the slides and finish off the topic. Okay, let me go back here, and then we already spoke about this one is the short circuit evaluation of conjunction idea, and then you can read through the slides, and also that's the solution for disjunction short circuit evaluation, right? And let's now consider some exercises. Okay, just go over it quickly. So short circuit evaluation always go from left to right, so that's the main principle. And then the order in which the operands are placed matters. It really matters. Let's see this. For example, when I say line number 10 over here, I really talk about line number 10. Let me just give you the example here. For example, you can see line number 10. So this is really the branching condition, right? What if we change that to, for example, this? If we simply put the expression to be guarded right at the front, and then those guarding constraints after that, apparently it would be too late, right? So what if input I is such that it's less than 0? Less than 0 is actually supposed to make this one false. But before you can evaluate this, you would already have crashed already, right? So it would be a crash. What if we have some invalid index, let's say that's such that it's larger than or equal to ns.length. So that will definitely make this one false for sure. However, before you can evaluate this, you would have tried I already on NSI, because the evaluations go from left to right, right? Remember the principle. So in this way, in this one here, even though you have the good intention to write the valid indices constraint over here, but you put them in the wrong order, so that's not good. Similarly, let's say this one here. Let's say I put it in the middle. So this one is exactly the exercise number 1 I gave to you. I'm going to leave you to read it. And then if you really want the solution, you can look at the slides, right? Okay, it's already here, but you can take a look. So the conclusion is it does not work always. In some cases, it will work. In some cases, it will not. The insight will be you will only be guarded by this particular constraint. So any invalid constraint that's going to make any invalid index that is going to make this false, you can be guarded by that. However, any invalid input that will only make this false, it will be too late for you to check it because you will already fail that particular invalid index here already, right? So that's the main point. And similarly, if I put here, I kind of swap the order. You can see I put this this one here rather than later, and also I put this one later rather than earlier, right? Just kind of play with different order. What about this one here? This one, apparently, any invalid index value that's going to make this false, we can properly protect NSI. However, any invalid index value that's going to make this false, for example, let's say something that's negative, it will be too late for you to check it. Okay, so that's why one will be crash, one will be works. Okay, think about this issue here. If you really still struggle, you can maybe speak to me and then I'll help you. But for now, I assume you might be just okay. So more examples for you. You can consider more combinations over here. I just give you 3 more over here. So I also talk about disjunction over here. Think about the same question over here. For example, for this one here, does this branching condition always work, or it might crash at some point? And similarly, for this one, does it always work, or it might crash at some point? And for this one as well. Okay, that's about the how to apply the short circuit evaluation on the in the context of array indexing. So you should really think about the problem we are trying to solve is really the same when we try to guard integer division. You just have to pay attention to evaluation order and also whether you're talking about conjunction or disjunction.